Hello friends, and welcome to a chat from the engineering desk. As you can see down here, I have this encoder that I took apart a couple of days ago. As you can see, with the microscope pointed at the disk. So there you can see three sets of lines. You got the roved lines. Let's see if I've got a pointy device. I'll stick in there. Over there, which is your A and B quadrature pulses, which is your speed and direction feedback. Then you have got your other lines, which is your commutation signals, UVW, which is your absolute position feedback for your commutation, because this is used to commutate a brushless DC motor. In other words, the rotor has the magnets in it, and the stator is a conventional three-phase stator. And then over there, let's see, there where the shadow is your marker pulse for 0 degrees. So that's the information that's being read by the camera on the read head. So let's see if we can observe that with the microscope and see what it looks like inside. There you can see the lines which correspond with those on the disk, like so, for the information being read. So as it moves over it like that, it reads the disk, the quadrature information, as well as the absolute position, the UVW signals, like so. That's what's going on there. So you can actually see the grating on the sensor over there, which produces your A and B signals as the disk rotates over it like that. Very interesting. So if I move this in a bit closer, I can't really zoom in too well with this microscope, I'm afraid. But when I do this, we do get a reasonable picture of what's going on there, like so. Depends on the lighting and the contrast, but there you can clearly see what's going on. That's what that looks like. Very interesting. Now, if this were a absolute encoder, like a grayscale encoder, there'd be lots of lines on this, and you'd see them appear in dark and light in formal places. A grayscale encoder looks quite a bit different. So instead of having the outer row of quadrature signals, you've got signals for each absolute position, and that outer row for the A and B quadrature signals are not present on an absolute encoder. And there we have it. What I might do is see if I can power this up and put the light source back, hook a scope up to it, see if we can get some pulses out of it, because the remainder of the disc over here is still in working order. So it's actually still a working encoder, despite the active vandalism that has taken place here. Electrically it's still intact, and mechanically it's largely intact. It's just missing a little bit of the glass, which I removed with the pliers. So all I got to do is over here buzz out the supply and the A and B signal, then we can put a scope on it and play with it. I've still got the light source over here, which I can solder back and then have a play with it. But I thought you'd like to have a see what the inside of the scope looks like, the encoder looks like. There's the ICs. What are they called? Upside down and spin it around. Those will be line drivers. Of some flavor. Yep. Because this produces differential signals out on 6 channels. So you've got line drivers. There's for each signal out there's a complement, with them being 485 signals out. So that's what your ICs look like over there. Not a heck of a lot else going in here that's of interest. There's some supply stuff on the back there. It's a double-sided board. I'm not sure how many layers are in it. Hard to see. It's very interesting observing the world through a microscope, that's for sure. That useful. But I think for now that's going to wrap up this video. Been rambling on for a few minutes, and I think you've seen what you wanted to see. So thanks for joining me here for a quick talk while we have a look at this here piece of equipment and what goes on inside it over there, like so. And depending on how you get the light on it, and see a bit of the there you go. There you can see the entire thing. You need some contrast. It's a tricky thing to light. That's what it looks like. Encoders have come a long way in terms of this technology here with the optics and the electronics and so on. A lot going on in there. It's good stuff. Not even sure who makes this. I don't think there's a part number on that. Some kind of secret source. That's good. Anyhow, Thanks for joining me here for this. Have yourselves a wonderful day further, ladies and gentlemen. Take care. Thanks for being here, and we'll see you for more. Take care. Cheers.